All right, good afternoon. Today, we are going to learn how to factor more quadratics. And I've highlighted the problems that I hope to go through today as a class, problem number 25, 27, 30, and 31. Just as a reminder, um, underneath this practice, I have worked through so many problems already. And if it ever chooses to load, so like I have already done problem number 21, 22, 23, 24, 26, 28, 29, and 32. And so I tried to choose 4 problems that I have not done yet. All right, so let's go ahead and begin. What I want you to notice about these is that they look very similar to the other day. We have 1, 2, 3 terms, and we have a quadratic. But this number right here is not a 1. So you cannot just jump straight to the factor x like we did before. Before we'd put a 6 here, 7 here, and then we thought, oh, that was really easy. But we cannot do that because of the 2. Same thing here, 1, 2, 3 terms quadratic. A is what we call 3. We cannot just straight do the x. We cannot do that. Okay, 1, 2, 3 terms, again, A is not 1. And there's no GCF. 2, 7, and 6 are all relatively prime. There's nothing that goes into 2, 7, and 6. There's nothing that goes into 3, 14, and 24. Well, there is 1. 1 goes in all of those, but we don't really care about 1 when we're factoring. 5, 22, 21, no GCF. Okay, here, A is not 1, but there is a GCF. Looking at that, the biggest number would be 2. So you would factor out a 2 first, and then see what you get. But what I want to start at is number 25. And I see I have 1, 2, 3 terms, but this number is not a 1. But you may notice is that actually this has a GCF of 2. So I'm going to go ahead and factor out a 2. What's left over? Well, if I take 2 out of 2x squared, I get just x squared. I took 2 divided by 2 and I got 1. 8 divided by 2 is 4. That's negative 4x. And 6 divided by 2 is 3. Now from this step, you could do exactly what we did last class period because A is 1. So I make the little factor x. I'm trying to find 2 numbers that multiply to 3, but add to negative 4. That would be negative 3 and negative 1. And my variable is x, so I put x minus 3. Try again on that one. Probably just type it up. Probably be easier now. So now I'd get 2, x minus 3, and x minus 1. And remember, if I wanted to check my work, I could type this in Desmos, and they're going to be the same graph, okay? All right, so sometimes you look at this and it's not a 1, but you could sometimes factor it out and make it a 1, and then do the same thing we did last class period. Let's go to 27. 27, A is not 1. 4, 4, and 1, the only thing that goes into 4, 4, and 1 is 1. So I have to teach you a new factoring technique. Here's the process. You're going to take this number and this number, and you're going to multiply them together. And that's going to go on top. 4 times 1 is 4. So again, I took this number times that number. 4 times 1 is 4. I still copy down this number down here. I still put that on the bottom. That's still -4. Now I'm looking for two numbers that multiply to 4, but add to -4. Let me think. That'd be -2 and -2. So -2 times -2 is 4. And if you add them, you get -4. Now, it might be tempting to jump to this step and go, oh, okay, x minus 2, x minus 2. And if a was 1, you would be correct. However, we need to take into account this 4. So we're going to actually take this 4, and this is called the slide and divide rule. We are going to divide this by 4 and this by 4. Now you might be thinking, okay, this is getting kind of strange. At this point, if this reduces, you reduce it. So 2 over 4 reduces to 1/2. So I'm going to rewrite this as, let's see, x minus 1/2. And they don't always reduce. So I don't want you to expect that they always reduce. 2 over 4 reduces to 1/2. You should know how to reduce fractions. I guess you could call that simplifying fractions. So you simplify the fraction if you can, and then you take this number, if there is one, and you slide it to the front. You take this number and you slide it to the front. So what I get now, putting all that together, I get 2x minus 1 and 2x minus 1. Anytime we get the same factor twice, we call that a perfect square trinomial. So these are the same factor and they're the same solution. And I kind of saw this from the beginning. Whenever you get the same number there, you know both the factors are going to be the same. Okay, so this one actually has a shortcut. If it has 2 of the same factors, you just take the square root of this, 4x squared, the square root of this, square root of 1 is 1, and you get 2x minus 1, 2x minus 1. And so that's a shortcut I don't usually teach because you very rarely use it, but it does work. Remember, if you didn't want to write this down twice, you could put this down as 2x minus 1 to the second power. Okay. I had thought about doing 30. 30 looks a little different. So before we start 30, I want you to notice that it only has 2 terms. If I count this, I got 1 and 2. 9x squared and -4. This one had 3 terms. So that brings me to, hopefully you've seen this word before. They're called perfect squares. On a multiplication table, it's the diagonal. Okay, like 4 is a perfect square because it's like a 2 by 2 square. 9 is a perfect square because it's a 3 by 3. 3 times 3 is 9. And so it would be a good idea to memorize these numbers, 1, 4, 9, 16, 25, 36, because they have special properties. So when I look at 9, I go, you know what? 9 is a perfect square. How do I know that? Well, 9 if you think about that as a square, 9, and we'll do that would be 3 and 3. Three times 3 is 9. Okay, so 3 times 3 is 9. And then for the other one, 4. 4 is also a perfect square. Two times 2 is 4. Now, what I'm about to show you, and I forgot about the x squared. That's also important. So 9, yes, is 3 times 3. But when you look at the whole thing, 9x squared, x squared can be broken up into x and x. So putting that together, 3x and 3x. So I'm just going to add an x there. Let's see. Because 3x times 3x is 9x squared. 2 times 2 is 4. Now this is called factoring by difference of two squares. Notice I have 1 square, 2 squares. And then most importantly is this minus. See how that's a minus 4? If that's a plus 4, we get imaginary factors. But because it's a minus 4, here's all you do. You take your 3x, take your 3x, put it here, and here. You take your 2 and you put it here and here. Now I want you to notice that these are almost the same factor. The problem I just did up here, these were the same factor, they were both minus. And so whenever they're both minus or both plus, so whenever this is, I should be talking about this, when this is a minus and that's a minus, when you distribute, you get 3 terms. If that's a plus and that's a plus, you distribute and you get 3 terms. So the only way you're going to get 2 terms when you distribute is if you make this a plus and that a minus. So let's think about that. If I take 3x times 3x, I get 9x squared. If I take 2 times negative 2, I get negative 4. And then the middle term, if I take 2 times 3x, I get 6x. And if I take 3x times negative 2, I get negative 6x. So this makes positive 6x. That makes negative 6x. You add them together, they go away. And so that's why it's important when you're trying to get something with only 2 terms to make sure this is plus and this is minus. You could also do minus and plus, same thing. But in order for that middle term to cancel, the first term should be the same. The second terms should be the same. The only thing that would be different is a plus and a minus. So we call this, in case you want to go on YouTube and look for more, this is factoring. I don't need it that large. Factoring difference of 2 squares. That's what that process is called. Okay, let's go look at number 31. Number 31 I look at this and I go, okay, is there a GCF? Is there a GCF between 16, -40, and 25? I start with the smallest number first, 25. 25 goes into 25, but 25 does not go into 40. The next largest number that goes into 25 is 5. 5 goes into 40, that's 5 times 8. 5 goes into 25, that's 5 times 5. But 5 does not go into 16. It's like 3 point something. So I tried 25, I tried 5. The only other factor of 25 is 1, which we don't usually care about. And so I have to do the process of taking 16 times 25. And this is when it's good, if you recognize that 16 is a perfect square and you recognize that 25 is a perfect square, it's actually easier. Because, I mean, let's think about it. 16 times 25, I mean, I don't even have that memorized. Not the best way to get it, but it'll work. 16 times 25 is 400. So using the same process I said, you take 16 times 25, you put 400 here. It's a large number. And you bring down the -40. And you're trying to find two numbers that multiply to 400, but add to -40. That would be -20. And -20. Anytime you get the same number twice, your head should be going to what's called a perfect square trinomial. And so instead of finishing this, trying to decide if I want to show you the shortcut or not. It's probably easier. So what you would normally do, and you can't do this in all of them, you would go x minus 20, x minus 20. But remember, you have to divide them both by this number. (16 and 16). And this is the process that you're normally going to follow. 20 over 16, let's see, 16 doesn't go into 20. The next number that goes into 16 is 8. 8 doesn't go into 20. 4 goes into 16. Oh, 4. So I'm going to divide them both by 4. 20 divided by 4 is 5. 16 divided by 4 is 4. So I get x minus 5/4. And of course, it's the same factor. So I'm going to get x minus 5/4 because I reduce that and I get 5/4. Now, if there's a number left here, you slide it to the front. You slide it to the front. And you're going to get the same thing. So you're going to get 4x minus 5. Here, I'm going to get 4x minus 5. If I'm feeling lazy, I could just put this to the second power. 4x minus 5 squared. Now, if you notice that those are the same number, what you could do instead is you could take the square root. Square root of 16x squared is 4x, so you just put that down twice. Square root of 25 is 5. And then you just copy down this operator right here. Copy that down. If it's a negative, you make it a negative. If that's a plus, you make that a plus. But that only works if you get the same number twice. That was my only plan to do those 4, but I feel the need to kind of show you one that's not a perfect square trinomial. So for example, this one has no GCF. I can't take the square root of 2. I can't take the square root of 6. So on this problem, see, I make the little x. I take 2 times 6, and that's 12. I take this number, 7, and I put that here. And I ask myself, what multiplies to 12 but adds to 7? That's 3 and 4. Okay. I then take my variable with my 3 and my variable with my 4. So I'm going to get x plus 3 x plus 4 and notice we did not get the same factor twice, so this is not a perfect square trinomial. The only thing I need to do now is I need to take this 2 and divide both of these numbers by 2. And I'm glad I chose this problem because there's different things going on. 3 over 2 does not reduce. So what do? Well, we'll just write that down again, x plus 3/2. You're going to eventually slide the 2 over. 4 over 2 reduces. 4 divided by 2 is 2. So I put x plus 2. Now there's nothing to slide here. I mean, you could think of that as over 1, slide the 1 to the front, but there's no point. But here, you never write this as a fraction. So you're going to take that 2 and you're going to slide it to the front. So you get 2x plus 3 and x plus 2. Notice this was not a perfect square trinomial. We did not get the same number twice, whereas the one we just did, where'd it go? 30? This one was a perfect square trinomial. We got the same factor twice, so that's why you could do a shortcut, but you cannot do a shortcut on the first one. All right, I think that's enough to get you started. Remember, if you get stuck, to pay attention. There's a few things going on. A problem like this, that's exactly how you would do it. You're going to do the same thing. 21, 22, and 23 are all the same. 24 has a GCF, so you're going to factor out the 2 first and then do the same thing as 21, 22, 23. I did 25 for you. And notice 25 had a GCF, and then A was 1, so it was a lot easier. When A is 1, it's super easy. 26, no GCF, so you're going to do the little x. 6 times 28 is going to be kind of a large number. I should say 6 times negative 28. But notice 21, 22, 23, 24, 25, 26 all have 3 terms, all have a quadratic. And sometimes it's a 1, sometimes it's not, sometimes it has a GCF. 27 is what we call a perfect square trinomial because I could take the square root and the square root shortcut. 28 is a perfect square trinomial. And then 29 has 1, 2 terms. With a minus, you're going to factor this difference of 2 squares. Okay, here, this was factoring by difference of 2 squares. This one will be factoring by difference of 2 squares. Difference of 2 squares. So I think that's enough to get you started. Look at the videos if you need help. And I wish you all a good day, and I hope to see you all again soon. All right, I'll see you later. Bye-bye.